In this example, we are looking to go backwards. We're looking to take a graph and try to figure out which equation is a possibility and what the pieces would be connected to it. So for both of these, we have some sort of an amplitude and some sort of a potential period adjustment. We're not quite to this graph shifting left or right or a midline shifting it up and down. So these are the two situations that we have going on. So first part of this is, would I be dealing with a sine curve or a cosine kind of a curve? Well, a sine curve is going to start at the origin, and we don't have that. So most likely, sine is not it. So cosine is a possibility, but a cosine starts at a high point, dips, and then goes up to a low point. So right on the y-axis, we're not starting at a high point, we're actually starting at a low point. So that actually means that we have a reflection happening. So we can deal with that by just making our amplitude negative. And then the second part of this is it's reflected, and then how far down does it go? So it's ranging between a -4 and a +4. So our amplitude is 4, but it is reflected. All right. So we're looking to do a cosine curve, and we have a -4 that's going to be sitting right there. All right. So far, it's a -4 cosine something. So this something is all going to be dependent upon if the period gets adjusted or not. So if I go from low point to low point or high point to high point, that would be a 1 period, right? And it doesn't matter where I'm going, but this is 1 period, this is 1 period, this is 1 period. So for our period, our one cycle, our period is going from 0 to pi. So our period is pi. Normally, when we do one cycle, it goes from 0 to 2 pi. So that means we have some sort of a b value that's adjusting it. And so period is, we find it by taking 2 pi divided by that b value. All right, so right now, we know our period formula to be equal to pi. And so I can mentally do this where it's got to be 2 over 2 to equal this. So b is going to equal 2. If not, then put it over 1, cross multiply it, and then if you solve for b, you're still going to get a 2. So that finishes us up. So that is our graph, and let's graph it to make sure that it does exactly what it's supposed to do. So it looks great. We could throw this into Desmos, but we can also throw this into our calculator. We're just going to adjust our window to make it look like this. So we're going to clear out whatever we have. We're going to have a -4 cosine. Before I press that next button, let me make sure that my mode is in radian. Okay, so that's good. So let's do -4 cosine 2x. And then I want to adjust my window to make everything fit. So this graph goes from, let's just take it from -3 pi over 2 to +3 pi over 2. So -3 pi over 2 is some decimal, +3 pi over 2. And it's going by pi over 2's are the kind of the marks here. So pi over 2. So I've set the horizontal to make it look exactly like this. And then we're only going to go from a -4 to a +4. And then I press the graph, and this thing should look exactly the same thing. All right, it's just cutting it off here and cutting it off right there. And that's it. So that was taking a graph, putting some pieces together, figuring out, is it a sine or a cosine kind of a curve? What's our amplitude? Is it reflected? Is the period being adjusted? And then eventually we can use a sine curve, except a sine curve starts here. So there's a way to horizontally shift the graph, but that's on a different video.